Hello everyone, this is Ketisha. In this video, I'm going to go through the AQA Physics Paper 2 Higher Tier from 2025. Question number 7 is on the topic of magnetism and electromagnetism. Figure 7 shows some apparatus used to demonstrate the motor effect. So you have the magnets from the top to bottom, okay. Connections to the power supply, there's two metal rails, and across it is a copper rod. When the switch is closed, the copper rod accelerates. It should accelerate between either in the direction of D or B. Which direction is the acceleration of the copper rod? Now, for that, you will be using Fleming's left-hand rule. Now, remember, Fleming's left-hand rule is your left hand, your thumb and first two fingers held perpendicular to each other. So, your thumb, first finger, and your second finger, this is the force, magnetic field, and the current. Now, the current is going from positive to negative, so current is actually in this direction. I is towards me. Magnetic field is from top to bottom, from north to south, which means the force is acting in that direction. So it will be towards B. .2. The copper rod has a mass of 5 grams. The length of the copper rod is in the magnetic field is 0.07 meters. The magnetic flux density is 0.3 Tesla. Calculate the initial acceleration of the rod when the current in the rod is 2 amps. For 5 marks, again you are using two equations. First, we can find the force using the equation F equals BIL. B is the magnetic flux density, which is 0.3. Current is 2 multiplied by the length is 0.70, which would give me 0.042 newtons. Then I can use F equals MA. Now, in this paper, we have used F equals MA at least 3 times now. Usually, they just ask once. Right. So, 0.042 equals the mass of the rod was 5 grams, isn't it? Yep. So, now 5 grams is 5 divided by 1000 will give me 0.005 kilogram. It has to be in kilograms. 0.005 multiplied by the acceleration. Acceleration equals 0.042 divided by 0.005, which will give me an answer of 8.4 meters per second squared. Figure 8 shows a simple motor. There's a magnetic field between the two permanent magnets. When there is a current in the coil, the magnetic field is produced around the coil. Explain how these magnetic fields causes the coil to rotate, continuously rotate. So, for the coil to rotate, there has to be a force on, let's say, side AB or arm AB, up or down. And there has to be an opposite force on the side CD. Now, magnetic field is going from north to south in that direction. Again, using Fleming's left-hand rule, if I work it out, the magnetic field the current is going away from me. So AB is actually, that arm is actually moving down in this direction. And since the current is actually in the opposite direction, CD is moving up. So it rotates. As it rotates, this wire, which is connected to the contact, or we call this the split rings, the contacts actually swap. So every single time the current actually, as soon as DC moves to this side, the current is still moving upwards. So every single time the wire actually comes to this side towards the north, it's always going up. So the wire is constantly moving down. And when it's the wire, the arm that is near the south end is always moving upwards. So how do we write this? Here's a model answer. The interaction of the magnetic fields produces force on the sides of the coil AB and CD. So before I move on to this, see, in any in any wire, current carrying wire, if you pass a current, there's going to be magnetic fields in circular direction. Now, when that happens, this magnetic field around the wire and this magnetic field from the permanent magnets, they interact, they oppose or attract, so it just pushes and pulls. That's what's happening here. So the interaction of the magnetic fields produces forces on the sides of the coil A, B and CD. A, B and CD move in opposite directions. Each half revolution, the ends of the coil swap from one contact to the other. So current in each side of the coil is reversed. So the forces on each side of the coil is also reversed. Here, you don't really have to mention which way it's going up, but my explanation was to help you to understand it better. In figure 8, the coil of the motor is in a horizontal position. Now, if it's in a horizontal position, which is basically like this, straight. So AB is on the top, CD is over here. Explain why the resultant moment on the coil is 0 when the coil is in a vertical position. Now, when it's in a vertical position, it will be in these two contacts will be actually between over here and this point. So that means there will not be a current. So there will not be a magnetic force. So there's no acting moment. There is no current in the wire, so there is no magnetic force acting, therefore there is no moment. We bring that as well. That brings us to the end of this question, and I will see you in question number 8.